we are going to start a new series on C++ object-oriented programming. What is object orientation first, before we get to the topic? Object orientation, it is a programming technique where you divide your program into separate objects while not allowing outsiders to mutate or have access into your internal data directly. In object-oriented programming, we have four concepts: encapsulation, inheritance, polymorphism, and abstraction. In this episode, we are going to cover encapsulation. We are going to explain what are classes, what are objects in this episode. If we start by defining them, encapsulation, it is the process whereby you restrict the outsiders to have direct access to your data to mutate it in any way. In other words, you make your data unavailable for outsiders, for other classes outside or from outside the class, right? What is a class? A class is a collection of properties and methods that are common to all objects of one type. So a class is whereby you collect all data and methods that are common to a certain object. Let's say if you create a class for, let's say, a calculator, everything which is associated with the calculator will be inside the class, like buttons, a function which it's in the multiply button, or the function that is in the equals button, that will be in one class, which will be called calculator. Then we have another keyword which we call it an object. An object, it is an instance of a class. So one might be asking at this point, what is an instance of a class? Let's say since we are creating a calculator, right? Keijo created a calculator, the first calculator, and they implemented the functionality of the calculator and stuff. For them to create multiple calculators from that one calculators, they created many objects of that calculator or that class of a calculator. For all of this to make sense, let's get to code blocks, create our project, and start creating our class. Then we'll explain this concept more deeply as we do them. First of all, we're going to create a new project in our code blocks, C++. We're going to name this project next, finish. At this moment, we have a basic C++ program that you first wrote when you started doing C++. What we are going to do now, we are going to create a new header file whereby we'll be storing our class, where we will create our class. In that way, we are trying to separate our code into many files so that we don't end up having one long file which may be hard to read at some point. Because if you break your project into many scripts, it's easy for you to go back to your code, because if you want a class for calculator, the class it has its own header file, and the name of the header file. If you want the class for your cell phone, for instance, and stuff, it has its own header file. So what we're going to practice in this series is to create each and every class to have its own header file. It is possible to create many classes in one header file, but that's a bad practice, I will tell you. So what we're going to do, we're going to create a new header file, and then it will be header file. We are going to name our header file, let's say, let's start by creating a simple shape so that we don't complicate everything while we're still trying to explain. So in this episode, we'll be creating a rectangle. What's common in a rectangle? In all rectangles that you will find in your life, each and every rectangle must have a width. Each and every rectangle must have a height for it to be a rectangle. It's a width and a height. If a rectangle has a width and has a height, it will definitely have an area, which is length times height. It will definitely have a perimeter, which is a sum of all the sides of the rectangle, right? So we can name this class a rectangle. There we go. We have our header file. Then inside this header file, we can include our. I don't think we need any header file as for now. We'll see as time goes on, as we progress with our shape. We have a shape which is called a rectangle. In this case, we want to create a class for a rectangle. We said a class, it is a collection of properties and methods that are common to all objects of one type, right? So what are the properties and methods that are common to a class, to a rectangle? We have your area, your perimeter, your height, and your length. All rectangles must have those four, right? So what you're going to do, you'll say class, then you give it a name, rectangle, right? That's how you create your class. This is a class. Then inside a class will have three scopes, which is a public scope, which means anything which is under public can be viewed from outside the class or can be accessed directly from outside the class. It will have protected scope, which will cover later on when we move to inheritance and stuff. Then it will have private state or scope, which we will also cover in this episode. Private scope is where you'll store data that you don't think it's necessary for you to access outside the class or for any class outside to have access to that data, right? So we said we'll have a public scope and we'll also have a private scope. We'll cover protected in the next coming episodes. In the public, anything that will be accessible from outside the class, right? In the private, we'll be having anything that you think it is not a must to access from outside the class, right? So what you'll notice as a common trend in object-oriented programming, not to say it is the only way to do it, but it is a most common trend. In private, you'll usually put all your variables. Let's say if you have the variable for height, you have the variable for length, each and every variable, usually you'll put it under private, except if that variable is a constant that you need to access outside. But most of the time, you'll notice that variables are always placed under private, which is not a rule, but it is a common practice in object-oriented programming. So what we're going to do, we'll create a variable, height, then I will create a variable for width. Then we said each and every rectangle has an area and it also has perimeter, right? So what we're going to do, since you will need the area for some other things outside the rectangle, let's say if you want to add all the areas of the rectangles that you have, or you want to know at some point when you in the project that you are building that what is an area of a certain rectangle, when you want to compare two rectangles, which one is big, based on the project that you will be doing at that point. So it is reasonable to place your function to calculate area in the public scope. And what you'll notice, there is a common trend again. All methods will be placed under public. Reason being, you'll be using those methods to access all your variables here. Let's say if you had to create a rectangle whereby the user of your program want to know at some point what is the height, want to know at some point what is the width. we are going to create methods which are going to return your height and return your width for you. So that when a user requests for height, you can limit the things that they can do with your height and your width. That becomes more crucial when you deal with personal data. For instance, let's say if you're making a system whereby you'll be dealing with people's, let's say, school data, right? Each and every student will be having a student number. But a student can access the student number from outside the class, even though they cannot change their student number, because their student number is a number that they're given as an identification for them in that institution. So that's why you'll put your variables here, and you'll put each and every function that you'll use to access or mutate the variables under public. That will give you full access on what you want to do with your variables. So what we are going to do in our case, we said we want a function. We also want a function. Oh, let's say maybe the user will also want to know the height of the rectangle. Maybe a situation whereby they want to compare which it's taller than the other. So we'll say function and also height. Those are the functions that we'll be having in our program at the moment. If we need others, we'll add them later. Another important thing in object-oriented, your classes that you'll be creating, they'll be having constructors. What is a constructor? A constructor is a function that is immediately called when an object of that class is created. When you create an instance, let's say you create an instance of a rectangle, you want a rectangle which is 50 by 50, right? In that case, when you start creating that instance of a rectangle, the constructor of that of rectangles will be called and perform a certain functionality which we'll put inside that constructor, right? Usually we put that's where we initialize values for our variables. Since you see here we don't have initial values, if we were to come here, how do we make a constructor? We'll just rewrite the name of your class. Constructor name must be the same as the name of the class, so that the class will know this is a constructor. It doesn't have a return type. So inside here, you'll put logic. Let's say you wanna make the height to be equals to, let's say, 10, and you wanna make the width BL, width to be 5, for instance. Right? That's the first thing you want to see when you create an instance of this class. We'll come to creating a method to calculate the area. Let's say the method returns a double. It will be double calc area. We'll say return dpl 8 times dpl width. We'll create a method to calculate the parameter which will return a double again, which will say calc, not calc, but calc perimeter, like that. Then what we're going to do, we're going to return 2 times dpl height plus dpl width, like that. Then create a function to access the height and the function to access the width. The word that we usually use for the function that are used to return our values as they are from the private area, if you want them outside the program, we call them getters or accessors. In the near future, we'll see mutators, which are methods which are used to change these these variables in the private space. Then let's say we have a getter for height. Our getter must return a double, which will say get height. It will return height. Same applies to width. It will be double. Get width. Which will return dpl width. Another thing, in your class, it is not a must to put the implementation of the methods inside the class. You can create a header file which has the class, and instead of putting in implementation, you just put the signatures of each and every class that you'll be having inside that each and every method that we'll be having inside that class, and then put the implementation in a different file which you call implementation file. So as you can see, we have a method that is responsible to calculate the area. It will return it, calculate it and return it. There's a function that calculates and return the height, the perimeter, and then we have a function that we use to get the height. If you want to know how tall is our rectangle, we have a function that will return a width if you want to know how wide it is our rectangle. So if you come in the main, another thing before I forget, the concept of object-oriented programming that we have covered here, it's called encapsulation. The rectangle has a height and a width. So we have blocked direct access from this data, meaning if you're outside the class, you cannot directly access these two variables, which can be many variables depending on the class that we are dealing with, right? We have blocked direct access to these two variables, and those two variables can only be accessed by the methods up here. So that's encapsulation. So what we're going to do under here, we'll first include our class, our header file, which is called rectangle, right? Then we'll create an instance of that rectangle. Let's say rectangle. Then we'll say reg equals to rectangle. Like that. That's how you create an instance of a class. We said at the beginning of the episode, we said an object is an instance of a class. So by this line of code, we have created our first object in object-oriented programming. So what we have covered so far, we have covered encapsulation, which is restricting direct access to the data of a class. We have covered classes by creating this class, just say using this keyword class and naming the class, opening your curly braces. That's how you create a class. We have covered what is an object. An object, it is an instance of a class. How we create an instance, you'll just say the name of the class, then you name your instance. This can be anything. It can be Buhle, if you want to name your rectangle as Buhle, but in this case we'll just call it rec, right? Then again the name of the class and open and closed parentheses. So if you were to come here and say let's say cout, so that we know what we're shouting, we'll say rec dot area. We want to calculate the area of the rectangle. If we go on and calculate the area of the rectangle, of our rectangle, let's see, is there any error? Oh, there's no error. It says our error is 50. And if you can come here to our rectangle, we said immediately when we set our data, we didn't assign our variables to anything. But we said immediately when we create an instance of this rectangle, it must automatically make the height to be 10 and make the width to be 10, right? And this is what we call a default constructor because it has no arguments. And then we'll get two constructors that had arguments soon. So what happened here when we created this object here, since we have this object, since we've said it is equals to the default constructor, it went to this class and checked what it needs to do when we call a default constructor, which there are two things that it needs to do, is to take the height and assign it to 10 and take the width, assign it to 5. Sorry. If you can multiply your height by your width, then you will be able to get your 50 as your answer. If you can check again, let's say we want to know the perimeter, now not the height, we'll say calc perimeter. Our perimeter is 30. If we can come here again, in our rectangle, if you were to say 10 plus 10 plus 5 plus 5, you are going to get 20, because 10 plus 10 is 20 plus 10, which is 30. So we have created our class, we have created an object. This is our class, which is named rectangle. We have created our object, which is named rec. Then we have implemented encapsulation in our class, which is hiding direct access to these variables inside private. And then we have covered everything that we needed to cover in this episode. But before we end the episode, I wanted to show you that you can have many constructors as you want. So let's say if you want to have the ability to assign your own width and your own height when you create an object. So what you can do, you can come here, create another constructor. You can have as many constructors as you want. You say double, let's say width, like that. Then you'll say double, let's say height, like that. Then you'll put the logic here. But even with the constructors, you can just put the signature like this and put the implementation on the end on the implementation file separated from this header file. But in this case, since we're creating a small class, we're just gonna mix the implementation, put the implementation inside this class. So what we are going to do here, we'll say tpl height is equals to height, like that. Then we'll say tpl width is equals to width, right? Then if you can come here and check, if we were to put here, let's say we want a square, a square can be driven from a rectangle, right? So we'll say a square which is 10 by 10. Let's check what will happen. We must get a perimeter of 20. We have a perimeter of let's see, 40, because it will be 10 plus 10 plus 10 plus 10, which is 40, not 20, sorry. There we go, we have our 100. So we said we are able to get our height directly. We are able to get our height. So let's say get height, and let's see, we should get 10. Height and are the same, it's 10 and 10. So we'll just check height, you'll see height, it's 10. But now if we were to say, since this is our class on the header file, but now we are outside our class, we are on the main. So if we were to attempt to say, let's see, you see when you check what's inside the class, type the name of your object and you check what properties it has. It has a function which is called calc area. It has a function called calc perimeter. It has two variables called tpl height, tpl width. It has a get height, it has get width, it has rectangle, two constructors here. But here is the thing, if you notice very well, we have different icons here, right? This icon, these green icons, they mean that you can access that particular property outside the class, meaning even if you are on the main, you can still access that particular property. But these red icons here, they mean you cannot access that particular property outside the class. And then this plus symbol here represent your constructors, and these parentheses, they represent your methods, right? If we were to attempt and say, let's say 1 TPL height like that, let's see what will happen. You should get an error saying that we can't access it. TPL rectangle height is private within the context, meaning if we are outside this rectangle, we cannot access that TPL height. But if we were to come here and take TPL height from private, let's say, let's put it here for now, to public. Let's check what will happen. It will access it and it will show us the value of that TPL height. Here is the value. So that's what's called an encapsulation, meaning you are restricting direct access to the data of your class. I think that's all we needed to cover today. And thank you for watching this video. Check here for the next coming video, and subscribe here if you like this content and like the video. Share with friends and